Okay class, solution for question number 2. So we have the question here. We have two forces, F1 and F2, acted on particle O. Determine the magnitude and direction. So we have two things to find for this question. So when it comes to a question that has forces, direction of forces, we need to find its component of X and Y. So we have two forces, F1 and F2. So F1 is totally in y-axis. Okay, we don't need to resolve. So this is equal to F1y. But F2 class, F2 we need to resolve because it is in between x-axis and y-axis. Okay, so now how to resolve F2? So we have here F2. So we resolve to the nearest axis. So this is going to be F2x and this one is going to be F2y. Okay, to make it simpler ataupun to make it easily to be understandable, so we put everything in table. So we have table for x component and also y component. Okay, and we have two type of forces, which is F1 and F2. Okay, so you can draw a more proper table. Okay, so F1 and F2. So we have to look at the diagram here one by one. So we focus on F1 first. Okay, focus on F1 first. Okay, so for F1 we have F1x equal to 0 because there is no F1 in x-axis, and we have F1y. So F1y is equal to 10, okay, which is equal to F1, total F1, 10 Newton. And for F2 forces, you need to find F2x and also F2y. So this part is a bit tricky. It's not tricky, it's a bit it's not that easy, so you need to think. So we have F2x here, so we have F2 and we have angle. So we need to generate the equation for F2x class. And one thing that you have to always remember, that the direction need to be considered. So the direction of F2x here is to the left, meaning your F2x is going to be negative. So after you put the sign, then you can write down the equation. F2 angle is here. So if the angle is attached to that axis, meaning we put it function cos, okay, for that force. So F2 cos theta, so it's going to be negative 30 cos 30. Okay, and I have calculated the value. Okay, you're supposed to get negative 25.98. Okay, so that is for F2x. So for F2y, it is upward, if you can see here, meaning it is positive. So the equation is positive F2 sine theta. So it is equal to 30 sine 30, and when you calculate, you are going to get 15 Newton. Okay, so this is for total, the rule for total. So we need to add up all forces in x-axis. So you have to add up these two, 0 and negative. So you are going to put negative 25.98. Okay, and same goes for y-axis. So you're going to find total y. So 10 plus 15 is going to be 25 Newton. So to find the magnitude class, okay, magnitude means for resultant. Okay, so we can either write down FR or R. So it's up to you which one is proper or suitable to be used. So FR is equal to summation of force in x-axis squared plus summation of force in y-axis squared, square root. So substitute the values, negative 25.98 squared plus 25 squared. At the end, you are going to get 36.05. So actually, you have to proceed your calculation down here, but because I have a limited space on my screen, so I write it down in a row. Next, we want to get the direction. So direction can be represented by angle. Okay, so we will use tangent theta is equal to summation of force in y-axis, summation of force in x-axis. So it's 25 over negative, or you don't need to put negative sign, we just want to get the angle, equal to, so substituting all the values, then you can have your theta is equal to 43.9. And please remember, we need to state where is your theta. So how to know where is of the position of your theta? Okay, where is your angle? Is it? So where is your theta? So it depends on this value, class. So we look at this total value here. So for x-axis, it is negative. So when it is negative, when it is negative, it is to the left. And for y-axis, it is positive. So it is upward. So your angle, your resultant force is somewhere around here. Your resultant force is somewhere around here. So your angle here is supposed to be above negative x-axis. So it is the answer for direction. Thank you.